Iceland, and welcome to TFWE. I'm your host, Eric.
And I'm Christina. Today is day one of a three-part special on the geology of Iceland. Before we begin, we shall give you a brief introduction to the plate tectonics of the land.
Iceland lies in the North American and Eurasian plates. They lie on a divergent boundary, which causes the plates to drift apart.
Now we are going to send you to Jillian and Corey in the field to give you some of the energy underlying Iceland.
Here I am at the Great Geyser of Iceland. The geyser has a lot of potential energy when the water under the surface building up heat as the water is heated from the magma.
The geyser has a lot of kinetic energy when the water is released and shot into the air, when the pressure needs to be released.
Hi, I'm at Laki, where the eruption occurred only 227 years ago. The eruption that happened at this very spot had a lot of potential energy when the magma was building pressure within the volcano as the gases built up. It had a lot of kinetic energy when the pressure was released and the magma particles were shot into the air.
This volcano has mafic lava, meaning the lava comes out more easily, making more lava come out in the eruption. The volcano has mafic lava, which means the lava flows very easily, causing more lava to come out of the volcano in the eruption. The lava has a lot of potential energy when it shoots up into the air and a lot of kinetic energy when it hits the ground.
Wow!
That's amazing!
I know! Laki lies on the plate boundaries and potential energy builds up when the stress underneath the plates builds up as the magma moves and the plates do not. The plates have a lot of kinetic energy when the plates move and the stress is being released and the potential energy is being converted.
Underneath these plates are convection cells that make the plates move.
The convection cells, which are located underneath the plates, have a lot of kinetic energy because they are always moving, and kinetic energy is the energy of motion. Now back to Jillian and Corey.
I have made a slight move to the river of Fassa. The river has a lot of potential energy at the top of the headbank and a lot of kinetic energy at the
It also has potential energy inside the point bar and kinetic energy on the point bank. Back to you guys.
Thank you for the wonderful examples of energy.
Thank you for tuning in. I'm Derek.
And I'm Christina.
Bye.
Hello, Iceland, and welcome to TFWE. I'm your co-host, Christina.
And I'm Derek. Today's the second part of our three-part series of the geology of Iceland. We'll give you a brief description of forces.
For those of you who don't know, Newton's three laws are, number one, an object in motion will stay in motion unless an opposing force acts on it, and an object in rest will stay at rest unless an opposing force acts on it.
Number two, F equals ma, including inertia.
Number three, every action has an equal and opposite reaction, including buoyancy. Right now, we are going to Jillian and Corey on plate boundaries.
Obviously moving, and it is constantly moving, and it won't stop unless an opposing force acts upon it. As you can see, this river has a downward flow, and the river has a high acceleration and a high force, and the mass must be low. If the river has a low acceleration and a low force, the mass must be high.
I'm where the plate boundary occurs. Since this is a divergent plate, it includes all three of Newton's laws. For the first law, the plates remain at rest until enough stretch, which is the opposing force, builds up underneath and causes the plate to move. For the second law, the plates are large and contain a lot of mass, causing them to have a low acceleration in order to create the same amount of force outcome. Newton's third law has to do with the plate floating on the magma underneath. The plate floats because as the plate pushes down on the magma pushes up on the plate. Another example of Newton's first law involves a plate that Iceland lies on, and a plate Iceland doesn't lie. Where the Pacific and the North American plate is a subduction zone. Therefore, as the North American plate drifts away from the Eurasian plate, it slows down and the Pacific plate as they collide. So, the Pacific plate is the opposing force to the North American plate, which is in motion. And revisiting the location of the eruption that happened only 2 centuries ago, where the lava shot out of the volcano and the lava was pushing against gravity, causing gravity to pull on the lava, making it come back and hit the ground.
I'm at OK Mountain in Iceland. As everyone knows, mountains are made out of rocks. What most people don't know, though, is that when the pressure on the top layer of rock, which is caused by which is caused by the high mass pushes down, so the lower layers of rock push back up. Look, it's a plant. Did you know that when plant roots go into the cracks of the rocks being the object at rest, and the plant roots being the opposing force, they create pressure as they go, causing the rock to shift. Now back to the station.
That's all for today. I'm Derek.
And I'm Christina. Bye. Hello, Iceland, and welcome to TFWE. I'm Christina.
And I'm Derek. Today's the third and final part of a three-part series of Geology of Iceland. We'll give you a brief description of waves.
There are three types of waves: P waves, S waves, and L waves.
Now, we're going to go to Corey and Jillian. Hey, guys.
Derek, we stand here again at Lucky before this bad boy erupted. There was an extremely large earthquake. The larger earthquake, the higher the amplitude of all three different types of waves. All of these waves can only occur through the mediums. The P waves come first in this earthquake.
Shortly after that came the L waves. Then, with the longest break in between two sets of waves, comes the L waves. The P waves are the least destructive, S waves coming in second, and L waves being extremely destructive. L waves are more destructive than S waves because up and down waves go faster than side to side.
This is the last part of our three-part series. I hope throughout the journey you learned a lot.
This is our last sign-off. I'm Christina.
And I'm Derek.